The next thing we need to bear in mind is environmentally limited resources. And what this means is these refer to resources whose location we know. We have perfected the geology and geochemistry or petrochemistry of identifying the location and the amount and so forth done. The next thing is our technology is good in terms of being able to extract it, smelt it, and transform it. That also we got under control. The third part is the environmental impact. In some cases, the environmental impact may be terrible. And so even though you know where it is and you know what to do with it and how, you may not want to do it anyways because of the deadly environmental impact. So that's what we mean by environmentally limited resources. So what are some of these impacts? The first impact is acquisition may result in significant disturbance to the surface and subsurface ecosystem. Whether this is vegetation, whether this is animals and insects, birds and whatnot. This can cause a disruption, and we could take a myopic view and say, what do I care? I mean, if some plants and birds are displaced, well, life on Earth seems to be very connected. Sometimes when you do certain things in some part of the world, it has a devastating and often unpredictable effect in other parts of the world. So it is very much an interconnected world, whether we are able to perceive it or not. And there are both overt and subtle impacts that can be felt. So that's the one. The second thing is water availability can be a problem. Acquiring something, ore dressing, smelting, etc. require a lot of water. Is it available, and how much of it do you need to spend? Again, acquisition and transformation calls for chemicals, cyanides and mercury and stuff like that. Pretty toxic material. And it's not just limited to your process, right? I mean, those chemicals are still there afterward. What do you do with that? Do they leach into the soil and elsewhere? So you got to talk about that. And then a last thing is that many of these factors come together. I've been talking about each of these one at a time, but they don't act one at a time. They all act simultaneously, and they happen especially as you start dealing with poorer grade minerals. You have to dig deeper. You need more chemicals and more powerful chemicals because these are leaner resources. And as I said before, these are always located far away from civilization. So in the US, in remote parts of Colorado or New Mexico or Arizona and so forth. So most of us enjoy these benefits located in places like Houston or Dallas or Austin. Much of the stress is felt somewhere in rural New Mexico or Colorado or Idaho or Montana. And you and I don't deal with the devastating effects of a shattered community for decades when a plant is abandoned, right? I mean, but it's still physically there and can continue even though it's not operating to cause damage to the groundwater and soil and so forth. So there's also a matter of social justice involved in all of this. Remote and worldwide, this is true. Places in Africa and South America, and certainly here also home in the US, there are these effects. So when we deal with lower grade ores, the problem gets compounded because of the following. And in one researcher's account, they are talking about what happens when you deal with, this is a prediction on what happens when you deal with poorer grade ores and you are located in a part that's remote, doesn't have, think about this, Arizona, New Mexico, Colorado, none of these are places known to have lots of water, right? So this is what can happen. It would be equivalent to opening 300 or 500 large open pit mines, how much you have to dig to get down, and you're removing 13 cubic kilometers of igneous rock per year. That kind of surgery of Earth's surface has is bound to have profound influences which we can't even predict for decades to come, and things that cannot be set right when wisdom dawns on you, because once you unleash something, certain things take its own course. The use of water anticipated to be about 20% the flow of Mississippi River, and using about half of Earth's energy resource. We talked about chemicals a while ago, right? And I should backtrack and give you some examples. When we are dealing with extraction of some materials, we use mercury sometimes to separate the good stuff from the bad stuff. Mercury is a problem. Sometimes we use cyanides because they react and then they separate A from B. But the mercury and cyanide, firstly they're toxic when you use them. They kind of linger and introduce toxicity in the ecosystem for a long time. In other cases, the ores we deal with, when you are dealing with copper or zinc, they are available not in bulk, they are available as a sulfide. It's copper sulfide or zinc sulfide. So when you go through the process smelting and you let products of combustion, sulfur is released, which then will become sulfur dioxide and manifest itself as acid rain. Likewise, when you have open pit mines where you are exposing newer and newer surfaces of earth, you are exposing sulfide bearing rocks, and the sulfur there also can oxidize, eventually become acid rain. Even after you abandon these open pit mines, you got huge surfaces of sulfide bearing stuff. You and I in Austin, Dallas, and Houston don't care about this, but the folks in New Mexico or Arizona or Colorado or Montana, these are rural communities which may not be in a great shape to begin with, and it would cause incalculable damage to these communities. So we got to keep that in mind. So what does this mean? What it means is these constraints indicate to us that it is poorer. We started off this lecture by talking about tapping into poorer grade resources. It can be done, but perhaps it ought not to be done because of all of the consequences I just mentioned to you. It also means that we must be immensely protective of our reserve base. Just because we have another 50 years or another 100 years, we shouldn't be wasteful. We should constantly look for new, and we should not give up usage. I don't suggest we scale back the quality of human life, but technology can often provide means of being more efficient. Think about this. Think about cars, right? From your grandfather's generation. We had huge gas guzzling cars from the 50s, and then by the 70s things changed, and today even the combustion technology, right? I mean, we moved to hybrids, and then we are moving to electric and so forth. So we're not doing away with cars, we're just having more efficient. Same thing with homes. We have green buildings and green homes and LEEDs and so forth. If you think about steel melting technologies, we have Bessemer furnaces, we have oxygen lance furnaces, we have induction furnaces. Each of these represents a different technology for doing the same thing, which is melting steel. And they stand on a scale different from one another in how much energy they use to do the same thing. So technology can be deployed to make sure that we are sparing in using the reserve base. The last part of this class deals with what's called cumulative supply curve. These are graphs that show the relationship between the price of a resource and its demand. And we have three kinds of supply curves which are shown in your handout. They are shown here. So we got A, B, and C. A is a smooth curve. B and C have sudden steps or jumps. So on the x-axis we have the cumulative amount or the demand, you might say. On the y-axis we have the price. In the first, you see a gradual increase in demand causing a proportionately gradual increase in the price. In these two, it is gradual up to a certain point, and then there's a sudden spurt in the demand, causing the price to go up. So we got A, B, and C. So what causes these three different types of curves? What factors influence them? There are three key factors. They're, basically geological factors. Then you got demand, human demand, which increases with population naturally, and new technology. The first two have a certain kind of impact, and the technology can have a second kind of impact. Geological and demand impact in almost the same way, same direction. So by geological, we mean what is the distribution of this material? Is it a log normal, like we saw in the beginning, or it's a bimodal, right? If it is log normal, it's a smooth curve. So you may expect the kind of supply curve we saw in A. Whereas if it is bimodal, you would see a sudden spurt. And that's what you saw in B and C. Same thing with demand. If it's a gradual demand versus a sudden appetite, right? Right now, it would seem when you compare us today with maybe the 50s, even 60s, things where development was somewhat gradual. Today, development is unfolding in every part of the world. Population also is exploding everywhere. So it just depends on that. So both of them have a negative kind of impact. Now technology can have the opposite. It can bring these curves down. It can bring the price down by developing processes, equipment that are more efficient and so stretch resources. But so basically this class was to give you a sense before we get into product design and process design. We often come to the table with various opinions, right? I mean, we have our own intuitive sense about things. We watch news, we read papers, we hear friends and family talk, and we have a certain sense about resource availability. Is it too drastic? Are we going to run out of stuff tomorrow? Or we don't have to really worry about any of this stuff. Hopefully this class has given you a balanced perspective, but mostly to know where to find the right resource. A resource is legitimate if it is written by a scientist or an engineer with the right qualifications. They are a geologist, they are a chemist, they are a petrochemical engineer. The material you get is in a peer-reviewed publication. You have a lot of people in society. We don't have to name them. They may not have any background in science, technology, or engineering, and yet may be in an influential position arguing for one or the other point of view. You are a university graduate student and you need to know where to get your input from. With this, we will stop here today. Thank you.